Welcome back, students. Excuse me. In this video, we're going to cover Module 10, Topic 5, tangents. This is going to be page 1 of Part 2 of the. So it's Module 10, Part 2. You guys will get this in class tomorrow. I'm recording this the night before. So if you missed class on Tuesday, March the 4th, this is what you missed. All right. So again, first page of this second half of the packet. Standards for this particular video and topic, GR 6.1. That's solving mathematical real-world problems involving the length of a secant, tangent, segment, or chord in a given circle. GR 6.2, mathematical real-world problems involving the measures of arcs and related angles. And GR 5.3, construct the inscribed and circumscribed circles of a triangle. So we'll do that a little bit later. The objective for this topic, you guys are going to solve problems using relationships between circles, tangents, and secants. So let's just jump into this warm-up. Number 1, find the measure of angle ADB and the measure of arc DC. Okay, so arc DC, I'm going to say that's here. And angle ADB, that'll be right here. Okay, so we learned in lesson 4 that the angle is half of the arc. So for here, the measure of angle ADB is going to be 1/2 of the measure of arc AB. So you notice this arc here. So that arc measures 76 because they told us. And 1/2 of 76 is 38 degrees. So the measure of angle ADB is 38 degrees. This pen is not doing well, but we'll keep trying. Actually, I'll write in pencil underneath here. So for part 2 here, the arc DC. So if the angle's half of the arc is double the angle. So arc DC is going to equal 2 times the measure of angle DBC. So this angle. So 2 times 45 is 90. So arc DC is 90 degrees. All right, number 2, find the value of x and y. All right, so we've got this parallelogram or quadrilateral inside the circle. And we'll remember, let's see, and you notice we have y, x, and then a number. Well, our opposite angles are congruent, but that's a good indicator is when you see x on one side and y on the other, because we can never solve x and y together, and that's why I tell you guys that. The only time we can do that is when we already have x and we plug it in, or we already have y. But either way, we find we solve each for each variable separately. So just remember that. All right, let's start with x, and I'll do it in pencil on top. So x is going to be 7x plus 1. And I'm sorry about this camera. I just realized this thing is not happy with me, and I'm using a different app, and I apologize. So let me write everything and back away. But we've got 7x plus 1 is going to be equal to 105. We're going to subtract 1 from both sides to get 7x alone. 7x is going to equal 104. We divide both sides by 7. And you do that. Wait a minute. Oh boy, I messed up. All right, I'll tell you what. I can erase. I know you guys can't, so I'm hoping. I'm sorry, very sorry. I was wondering how we knew those were going to be congruent. No, that's not true. It's quadrilateral, so each opposite sides here are supplementary. So 7x plus 1 plus 105. So these two added together are going to equal 180. These two are going to equal 180. So now 1 plus 105 is 106. We got 7x. We still got 180. I'm going to subtract 106 from both sides. Again, apologies. So now 7x is going to equal 180 minus 106. I knew my numbers were just not acting right. So 7x is equal to 74. We divide both sides by 7. X is equal to 10.6. Okay. And then for y, these two equal 180. So 7y plus 1 plus 4y plus 14 equal 180. Give me a second, I'll clean all that up. Excuse me 1 second. Okay. Alright, so 7y and 4y make 11y. 1 plus 14 makes 15. And we have 180. Subtract 15. I'm going to scooch this over. It's going to be 165, 11y. So 11y equals 165. Divide both sides by 11. Y equals 15. Again, sorry for the focusing issues. I'll try to get it fixed as soon as I can. All right, scooching up the page. All right, so what is a tangent line to a circle? A tangent to a circle is a line or segment in a plane of a circle that intersects the circle at exactly one point. It does not contain any points in the interior of the circle. For a line that intersects a circle in one point, the point of tangency is the point at which they intersect. So in this case, line RQ, so this yellow line is tangent to circle P. So circle P, so it only touches it at that point, Q. All right, so a common tangent is a line or segment that is tangent to two circles in the same plane. More than one line can be tangent to the same circle, so as you're seeing below. And the shortest distance from a tangent to a circle is the radius drawn to the point of tangency. Okay, so right here, this line is tangent to both of these circles. See the line that connects the two, the center points of the circle. And see, this line's tangent to both circles from this way. All right, let's scooch down just a hair. I'm sorry. Okay. Theorem 10.11. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. All right, so I know that doesn't make a ton of sense at the moment. It will in a second when we put it to practice. But again, so a line is tangent to a circle if and only if it's perpendicular to the radius drawn to the point of tangency. All right, let's see. And then 10.11 at the bottom, tangent to a circle theorem. If a point in the interior of an angle is equidistant from the sides of the angle, then it is on a bisector of the angle. So, just like we saw this before. So if a point, let's see, just take this. So if a point, say it's here, and that's the same distance from here and here, or if it's here, it's the same distance here and here, then it has to be on the bisector of that angle. That's what that's saying. And I know, what does that have to do with the circle? Well, we'll see on the other page here. So just bear with me. All right, so we flip over page 2. Let me get my camera right again. Sorry, this is different stuff here. Okay. All right, so example 1, identify common tangents. We're on page 2. So you see the I do's on the left. Those are the ones I'm going to do. The you do's, those are the ones you're going to do. All right, so number 1, identify the number of common tangents that exist between the pair of circles. Okay, so this line touches both of these circles in one point. So here's 1. This one touches both at one point, so that's 2. And this, so that's 3. So 3 common tangents. I believe over here it's going to ask you to identify common tangents you're going to draw. Look on the other page. There's only 2 ways, I think, but either way, try that out. And I promise if you get stuck and you ask me in class, I'll get you. All right, let's scooch you a little bit up. Number 2, or example 2. It's number 3, but example 2, excuse me. Still on page 2. Identify a tangent. So number 3 says, AB is the radius of circle A. Determine whether BC is tangent to circle A. Justify your answer. Okay, so in order for this to be tangent to this circle, this triangle has to be a right triangle because it said it had to be perpendicular to the radius. That's what that weird stuff, I think it was theorem 10.11 at the bottom of the previous page. It said in order for this to be a tangent, that when you basically it has to be perpendicular. So this the point of tangency should be, if you went out from there and you, of course this makes a radius, that should still be a 90-degree angle. So that's a 90-degree angle. This is the right triangle. So a squared plus b squared equals c squared. So let's just see. So a squared plus b squared equals c squared. So a squared is 9, b squared is 12, c squared is 6. What's wrong with that? I think something's not right here. Okay, wait a minute. That's where I was confused. I was like, how's this the hypotenuse if it's shorter than the other 2? Remember, this is the radius, and this is the radius. That's 9. This is 9. So C is 9 plus 6. So it's 15 squared. Okay? Hope I didn't lose you. All right, so 9 squared is 81. 12 squared is 144, and 15 squared is 225. So let's see if 81 plus 144 equals 225. So if we add those two together, you get them. So you see 125 equals 125. So AB is a radius to circle A. Okay? Hopefully I didn't lose you there when I lost myself for a second. Okay. Again, number 4, I'm going to work the same way. Now, they tell you here this is 13, so I'm just going to give you the hint there. There's nothing to add like we did here. This is from here to here, or this entire line is 13. Okay, so there's your hint. All right. Number 5. This is example number 3 at the bottom. Use tangent to find missing values. So, it says QS is tangent to circle R at Q. So QS is tangent to circle R at Q. All right, find the value of X. All right, so we're getting into the hard stuff now. In case y'all, I know y'all thought the hard stuff's already been, and yeah, sure, but here we go. So just like up here, the one before, this should be, if this is tangent, this would be a radius, and this would be a 90-degree angle. So this should be a squared plus b squared equals c squared. This is your a, this is your b, and then this whole thing is your c. Okay, so see, we're going to have to know what x is. So that's where things are going to get a little dicey. So if a squared, so rq plus b squared, that's qs, equals c squared, that's rs. So let's just do it that way. So watch this. So RQ is A. I'm sorry, well, it's A, but it's X. Then squared. Okay, plus QS, that's 4. Let's see, make sure I'm doing this right. Yeah, 4 squared. Equals, so this is X plus 2. So this part's X, this part's 2. So C is X plus 2 squared. Okay? So we can take X squared down. We can't do anything with it. 4 squared is 16. All right, so this, I'll bring my little, so just to keep us right over here. So X plus 2 squared is X plus 2 times X plus 2, right? Okay, so now we got to FOIL this so we can pull that out of there. So our fronts are right here. X times X is X squared. Our outers, so here times here, that's 2 times 2 is 4. Our inners, 2 times X is 2X, and then our last, this was our last. And then our outers, excuse me, I messed that up, but so you got X squared plus 2X plus 2X is 4X plus plus 4. Okay, everybody agree with that? Well, hope so. X squared plus 4X plus 4X plus 4. Okay, so everything's still squared. We're going to put our like terms together before we unsquare at the end. So just bear with me. So we have an X squared here and an X squared there. We're going to subtract them from both sides. Boom, boom. Those are gone. 16 here equals 4X plus 4. And actually, we're solving for X, so we don't have to unsquare now. Isn't math confusing? All right, subtract 4, subtract 4. Those go. 4X equals 16 minus 4 is 12. Divide both sides by 4. X is equal to 3, my friends. That was a little confusing. Again, A squared plus B squared. This is going to be your 90-degree angle. That's where that's your hint. This is going to be X plus 9. That's your other hint. I know this one's a little tougher. So this from here to here is X plus 9. X plus 9. Okay, there's your hint. Okay, flip it over. Page 3. Yeah, this one's 4 pages. We're moving a little faster with me leaving the you-dos for you guys, but still don't want to make it too long. All right, number 7. Again, page 3. Sorry for the sniffles. Find the value of X. Find my notes here. All right, so we learned that if it's equidistant, it's an angle bisector. These two things here, basically shooting through all the bull, it's going to be AB is going to be equal to BC. All right, so AB are congruent to BC, which means they're also equal. So we're going to put these two equations equal to each other, and that's how we're going to solve for X. Plus 9 plus 9. So 4X is equal to 15 plus 9. 15 plus 9 is 24. Divide both sides by 4, and X is equal to 6. This is going to be the same thing over there. That's your hint. If it's congruent over here, it's probably going to be congruent over there. Let's see. I'm going to do number 9. All right, so a photographer wants to take a picture of a local fountain. She positions herself at point A so that the fountain will be centered in the picture. AB and AC are tangent to the fountain as shown. If the lengths of the tangent are given in feet, find AB. All right, so just like this guy up above, or the one that you're going to work on your own. In this case, AB is going to be equal to BC, and then we're going to solve for X, and then we're going to plug it back in. So because they're both tangent, they're going to be congruent. In this case, AC, because it was BC, I think, up there. Or something, I don't know. Okay, so let's just switch to pencil, because that pen's trying to die. 7x minus 9 equals 5x plus 5. The 5's smaller, so I'm going to subtract it. Oops. 7x minus 5x is 2x minus 9 equals, the 5 comes down. Add 9 to both sides. 2x equals 14. Divide both sides by 2. So x is 7. All right, well, they wanted AB. So if AB equals 7x minus 9, 7 times 7 minus 9, so 7 times 7 is 49, minus 9, so AB is equal to 40 feet. I said feet. Okay. All right, scooching down. Got a few notes here, and we'll flip over to the back page. All right, so what are circumscribed angles? A circumscribed angle is an angle with sides that are tangent to a circle. So circumscribed angle, this is inside, but its sides are tangent to, well, I guess it's that. All right, so theorem 10.13. If two segments or lines are tangent to a circle, then the circumscribed angle and the central angle intercept the arc formed by the points of points of tangency are supplementary. Okay, so what that thing is saying. So saying if, let's pick our colors carefully. So if QS and RS are tangent, QS, if these two guys are tangent to this circle, that means that angle P and angle S, so angle P and angle S are going to be supplementary. So these two angles are going to equal 180. Simple stuff. You just got to be paying attention. But if this is a tangent and this is a tangent, then this angle, and this angle are 180 degrees. Okay? Down here at the bottom, circumscribed polygon has vertices outside the circle. Outside. Can't see it, but they are outside. And then over here, not circumscribed. So you see, it says outside the circle. This one's in. See, this is not right because the circle is in there weird, and then this. Notice the difference between these two. All right, let's flip over. Page 4. Page 4. All right, so draw a circumscribed triangle. So in order to do that, we're going to first draw a triangle. Okay, not perfect, I know. And then see how my circle is touching here, here, and here. Okay, that's what makes it right, if it wasn't touching equally. All right, and then draw an inscribed. So for this one, so notice the circle touched the triangle in 3 spots. The triangle will touch the circle in 3 spots. Okay, simple enough. I wasn't going to just do one of those. All right, example 5, we're using circumscribed angles to find measures. All right, so for number 12 here, it says measure of EFG. So this guy over here, so notice we have our boxes. I'm just going to draw for you guys over here when you do your own. All right, so measure of this angle is this, the measure of this angle is that, find the measure of angle D. Well, we learned that these two guys are supplementary, so we're going to put these two equal to 180. So 19x plus 9 plus 10x minus 3. All right, so 19x and 10x make 29x. And then positive 3, negative 9. So 9 minus 3 is 6. So 180 is still here. Subtracting 6 from both sides. So we got 29x is going to be equal to 174. We're going to divide both sides by 29, and that'll tell us that x is equal to 6. So now we got to plug it in because they want angle D. Angle D was 10x minus 3. So measure of angle D equals, so 10x, which is 6, minus 3. So 60 minus 3 is 57. So the measure of angle D is 57 degrees. Okay. Number 13 is a you-do. Let's go down here to number 14. So JKL is circumscribed about circle Q. Find the perimeter of JKL. All right, so this, I'm going to show you guys a little trick. So the parts of the triangle that hang over the same, like so over here, I'm going to make them the same color. Okay, over there. Bob Ross, happy little accidents. Look at that. Look how pretty that is. Okay, well, so the cool thing is the colors match up. So this side of green is 7. This side of green is 7. 14, purple. The other side's purple. 11 over here. 11 over here. So what is our perimeter? It's going to equal 7 plus 7, which is 14, plus 14 plus 14, which is 28, plus 11 plus 11, which is 22. Or we would have said 7 plus 14 plus 7, plus 14 plus 11 plus 11 plus 7. Same thing. All right, so we add these three together. We got 50, 64. So our perimeter is 64. But that's all we do. The same parts of this triangle that hang over, they're all the same because it's circumscribed. Remember, it's gonna cut each of these in half, or in equal. It cuts it equally that it works that way. Just trust me. So when you do number 15, draw your triangle. Same color, same color, same color. Okay. All right, number 16 at the bottom. And this will finish off this topic. So number 16. Each polygon is circumscribed about a circle. Find the value of x. Then find the perimeter of the polygon. So, let's just start out doing my little color trick. So here. Here. And here. Okay. So this is 14, this is 14, this is x, this is x, this is 18, this is 18. So x here equals 26 minus 18. Understand? The purple's 18, the whole thing is 26. So 26 equals 18 minus x. Subtract both sides, or you got two negatives, but anyway, x equals 8. Okay. Now, so we know that x is 8. So that's 8, that's 8, that's 18, that's 18. So what's the perimeter? The perimeter is 8 plus 8 plus 18 plus 18 plus 14 plus 14. We add all those together. So 16, how did we get? Sorry, I'm looking at something else. So, actually, I'm looking at my calculator because I just don't trust stuff. Okay, so 8 plus 8 plus 18 plus 18 plus 14 plus 14. Our perimeter is 80, so I had the right answer. Some of those numbers were weird on that page. Okay. All right, so that's it for this particular topic. Hope you guys have a good night, and let me know if you have any questions.